So, chapter 4 begins a look at money. Before we're going to be able to convince management that it'd be a good idea to uh, come up to pay for an idea using energy management to save money, we're going to have to understand a little bit about the way management looks at money. And this is going to be a bit tricky. So, this chapter has quite a few formulas in it, and there are a couple ways to look at it. One way is mentioned at the end of the chapter, and that's to use software to to do these calculations. And there's calculators available online, but also there's, as you might guess, Microsoft Excel will do much of this work for us. And so I've made available several files for you to understand how the examples and problems are solved using this software. So again, we have to justify the capital expenditures. We have to explain why it's important to do this, and to do that, we have to understand the value of money, the time value of money, which a lot of us don't understand. Most of us have only looked at money in this way, and perhaps in buying a car and having interest compounded that way, or maybe the mortgage on a house, or perhaps some savings accounts. So things are a little different here when we're looking at taking money that the company has sitting aside to do work for the company, and so it's accruing interest somewhere. Well, if we're going to take that money out of some investment to put in a physical investment in the plant, we have to prove that the money we make on the investment is greater than the money that's being earned in the interest-bearing account. So different ways of looking at costs. There are expenses. And then, of course, we have these capital investments, from building the building to upgrading the building to buying new equipment to do the things that are required, uh, you know, to make the widgets, whatever the company's doing. Remember, the company is in business to make widgets or whatever the thing is. But so that has to be kept in mind, that replacing the windows or upgrading an air conditioner or air compressor or a heating system is considered to be overhead in many cases, and won't be looked at uh, as as important. So we have to understand some of this. There's a website shown here that the National Renewable Energy Labs has here. You can go to that on your own and poke around with that if you'd like. I just left it here on the slide. Different types of investment categories: buying the things. So what it takes to actually get it, perhaps install it, maybe train somebody and to maintain it or to use it, perhaps renovate it. There's permits involved in many of the things that we would make installations of. And then, of course, there's the cost of running the thing. It has energy usage. It has direct labor. It has the staff for the people who are doing that labor. And then if it's a large labor force, then that force is going to have some indirect salaries, some indirect funds that'll have to be paid. So then we discuss it a little bit here in this chapter. You'll read about that. And then finally, when it's all said and done, and the asset has no more value and can't be used anymore, it has to be removed. There could be a cost to removing it, but at the same token, it may have a value that it could be sold for a fraction of what you paid for it, and someone else might be able to use it. So, and when we look in the book on page 134, we're going to see that there's a really nice cash flow diagram that the authors used, but they didn't tell us how to do it. So I'm going to go to that for a moment, and let's take a look at that. So this is page 133, where they explain that they want to maybe buy a heat pump. And so on the next page, they're going to show us a graphic representation called a cash flow diagram, showing the expenses going in the negative direction and the energy and the amount of money that can be saved going in the positive direction. And so somehow we have to be able to calculate the overall value. And this is a very simple diagram that could be used to show, to explain why this may or may not be a good idea. So The details are shown right here. That's going to cost us $10,000 to install the heat pump. However, it'll save us $2,500 a year in energy costs for 20 years. Yeah, maintenance costs are going to be $500 though, every year for 20 years. And at the end of that 20 years, they expect to be able to sell that for $500. Probably put it towards getting a new one. Um, so we have to decide whether this is going to make sense or not. And so notice this diagram here. So they show the initial expenditure of $10,000. So even before it gets turned on and starts saving a dime of energy, we have to lay that $10,000 out. And maybe sometime during that first year, we'll have to do some sort of maintenance on it that's going to cost $500. At the end of that year, we will have saved $2,500 in energy. And that'll happen for all 20 years that they operate it. Finally, at the end of the 20 years, in addition to saving $2,500, we will also be able to sell it for $500. All right, so could also list it this way in the tabular method, as shown here. All right, so as you may have expected, I have an Excel spreadsheet that shows one way that we could do this. Not that one, but this one. So here's the heat pump. So we can show our initial cost. We've listed in here the annual maintenance cost and the amount of revenue we're going to make each year, and the scrap value and the lifespan. So I just put these cells up here and labeled them. EOY, by the way, stands for end of year. So at end of year 0, the day we put it in, we'll have made no money and we'll have spent $10,000 on it. For years 1 through 19, we will save $2,000. Now, how do we do that? Well, we said that we were going to make $2,500, but it's going to cost us $500 in maintenance. So when I click on this cell, notice it says C3. The amount in C3 is $2,500. Subtract from it the amount in B3, and we see that we've got $2,000 in annual savings. Year 20, not only do we have the annual value, but we also add to that the scrap value in D3, but still have to subtract the maintenance costs of C3. So, and then in the end, we add all those together, and you'll see the formula that I used here. I used B6, right? So the amount in B6 is going to be what we paid for it. And notice it's listed here as a negative $10,000. And to that, I have to add B7, the $2,000 annual savings, times the 19 years it was in service, plus the final value of B8. Now, I want to show you what happens here when I click in the cell, right? So when I click in the cell, it highlights up here, up in the formula cell, it's going to highlight the cells that are used in the calculation of it. All 4 are highlighted. And if I then use the arrow keys on my keyboard to move across, well, in this case, there are no other formulas. There are no functions involved in this, so it merely shows the cells. Now, because I've keyed up in here, I want to be careful not to click on any other cells, or it'll think I'm adding it to this formula. So to get out of this selection here, I have to hit the escape key. So now I'm free to get out of that. All right, so back here then. So that's what we just saw. 2 different ways of doing this. But what we haven't seen is how in the world do I make this? If I start with this tabular flow, how do I make this? Well, now that was an interesting scenario. So I did an internet search and I looked around as to how to make a cash flow diagram with Excel. And I was able to find a website where that was shown. And let's see if I have it here. I don't have it here, but I do have an example of where you can find it in our week 7 content. Okay, one of those was from a website called vertex42.com, which put together by a Dr. Whitwer, who's a professor at a college. So that file I think I can find over here, right? So this is the table that I found by John Whitwer. And so what I was trying to find this cash flow diagram, and this is what I found. So I read this whole sheet here. Read the whole sheet, explained it a little bit about how the discount rate worked. And it showed me all the formulas that are mentioned in this chapter, so that was fantastic. It showed me more chapters that I wasn't using in this, and it's like, holy smokes, I can't find this anywhere. So after a bit of poking around, I went to the guy's webpage and I sent him an email. and asked him, how in the world did you make these charts? And he sent me back a reply. All right. And so that reply I have copied for us here, right? Discounting factors in Excel. This is the sheet that we were just looking at here. So you don't have to try going to the web page. You can just download it here. And well, let's see if it's going to let me open. I'm going to cancel it. All right. So, so that's where we will find that. I also have the file here to show you. We actually had it open a moment ago. It's listed as cash flow diagram here. So under cash flow diagram, you'll notice Dr. Whitwer put this up, and he had a simple thing here where there was year 0 through year 5. So something had an initial cost of $40,000, and each of the years it brought $8,000 in the first year, $9,200 the second, $10,000 the third, $12,000 the fourth, finally $14,500. So it shows up here on this cash flow diagram very nicely. And there's some other things that can be calculated. We'll be getting to that later. I'm not asking you at all during any of the assignments for this chapter to make one of these diagrams. I'm not. But I want you to see that it's here in the event that you think this is something that you're going to want to do. This is a great resource for you to learn how to do this work. All right. Again, this part won't be necessary for what we'll be doing in class. I will be referring back to this page in a little bit. So, let's go back now to my PowerPoint. So there was our figure. There's a couple ways now we can talk about payback. Simple payback period, SPP cost analysis. And in this case, we're going to take the initial cost and we're going to divide it by the annual savings. Now, this is very rough, and it's the way many people, especially if we're doing things at home, if we're going to install solar panels or a wind turbine, the question is always, well, what's the payback on it? What's the payback? Well, if I save enough electricity each year, how many years will it take for the cost savings to equal the cash outlay? Well, that's a pretty rough way of doing it, and it's commonly used, and so that's something we need to know how to do, and we have an example in the book that's going to show us how to do that. So let's take a look at that now. We'll go back to the textbook right here, and we're going to see that we've got simple payback analysis, right? That's what we did with this. So it ends up paying itself back in 5 years, right? That's the way this thing worked out. In 5 years, it was completely paid back. Unfortunately, what that doesn't do is it doesn't determine that the value of the money I have in my hand today is worth more than the money that I'm going to be able to have in 5 years. I won't be able to buy as much money with $10,000 in. I'm sorry, I won't be able to buy as much merchandise for $10,000 in 5 years as I can today. And so this is one of the problems with simple payback. And so because of that, we have to try and figure out why that is. One of them is because that money could be sitting in an investment making some interest. So the $10,000 today in 5 years from now may actually be worth $18,000. Well, there's ways to calculate what that's going to be. Okay. Another reason is that there's what's known as inflation, and what that means is that things cost more in the future. So so not only am I taking money that could be earning interest in the bank, but I'm also hedging that against whether or not inflation is going to go up or down. So on 135 of the textbook, I've got a couple things highlighted here. How when we're trying to determine the value of money now compared to later, there's different ways to calculate for that, and we should always make sure that the cash or money flows against time should not be added directly together unless they occur at the same point in time. All right, what the heck does all that mean? Well, let's see if we can learn a little bit more about this using one of our spreadsheets. So I'm going to go back to the assignments that we have for the class, right? And example 4-2, we're going to take a look at simple interest, and we're going to compare that to compound interest. So bear with me now. The slides on this spreadsheet aren't exactly in, or the slides in this PowerPoint are not in quite the order I wanted to, but bear with me. This just serves as a guide for us anyhow. Here's the simple interest. Simple interest is charged only on the original principal amount. Okay, and in this case, they're showing the formula here. The overall interest is equal to the principal times the number of years that it's being borrowed for times the amount of interest for that period. Notice this simple interest is, we're only calculating the interest here. We're not calculating what the monthly or or what any of the payments might be. We're just calculating what the interest would be if, in this case, if we chose not to pay any of it back until the end of that period, right? Most of the time when we buy things, we don't do it that way. So in a simple interest manner, that we would just compound it this way. And so here's our first example. We're going to go back to the textbook, and the textbook shows that we've got the interest accumulated over a number of years, the principal amount, and the interest period. So they give us an example here. Example 4-2. Company wants to borrow 10 grand for 5 years of simple interest at 18% a year. This particular problem was written many years ago when 18% was common. In the late 70s and early 80s, interest was incredibly high, and luckily it's not that high anymore unless you're talking about a credit card rating. So here's the example. So they're going to take $10,000 and they're going to multiply that times 5 years times 18% a year, and it comes to $9,000. Cool. Well, we can do that with a spreadsheet. I'll pull this up here. So here's our $10,000, and I've added in, this is the number of years. Here we have the 18%, put in the percentage, listed in percent and not in a decimal form. And then the compounded interest, there is the formula where we literally multiply the three things together. Boom, boom, boom. So at the end of 5 years, what do you have to pay back? You have to pay back the $10,000 that you borrowed, plus the $9,000 that accrued in interest. Well, what did the $10,000 do for you? Okay, if it earned you greater than $9,000, and you're not worried about inflation or interest loss, well, then that might make sense to do that. Well, so that's using simple interest. We could also then use compounded interest, right? So I'm going to go back to the spreadsheet, right? And then the spreadsheet, they're going to tell us this is going to be the amount of interest is going to be added to, it's going to accumulate onto the original principal. So at the end of the first year, you don't just owe $10,000, you also owe interest on the interest from the first year. Watch what I mean here. So again, we'll go back to the textbook, right? So at the compounded interest, the first year I owed $10,000. At the end of the first year, now I owe $1,800, right? Because I take the $10,000 times the 18% times the 1 year, so $1,800. So now that $10,000 turns into $11,800. That becomes the amount owed at the beginning of the next year, right? And so now we're going to multiply 18% times the $11,800. And you can see how this is going to grow. And so at the end of 5 years now, the interest, just the interest, is $22,877. You still have to pay back the $10,000 you borrowed initially. Sounds like school loans, doesn't it? Let's go back to the spreadsheet and see what I did there. So again, we did the same thing here. It did the math for me, right? It took the 10,000 times the 18%, right? So here it took the amount of in E3, right? E3 is the 10,000, and I multiplied it times the amount in $4. $4 meant don't increment this, because I was able to just pull this down to get it to do years 2, 3, 4, and 5, and the same thing over here because of the $ symbol. All right, so there's my 1824, and so that ended up was the two things added together, and so this is the same table that we had before. Right. So that's comparing compounded interest to simple interest, and you can see why the bankers would want to have this type of interest, whereas not this type of interest. All right. So back to the spreadsheet or to the PowerPoint. Now we have these discounted cash flows. Okay, so discounted cash flows. This has to do with determining what money will be worth in the future compared to what it's worth now. So there's different ways to analyze this, and we're going to have several tables in the textbook and several examples. And I have them all worked out here. Every one of the examples that's in the textbook is listed in the textbook, and you can calculate them out. But I also have a spreadsheet for each one of those that you can look at and calculate. All right, so move back to the textbook. All right. These are the values that were listed before. I skipped over this page because frankly, I didn't think it belonged there. So here are the letters that we're going to be using, right? I is the interest rate, okay? I is the interest rate, also known as the rate, okay? N for the number of years, N years or N period, number of periods, right? We could think of it that way. Capital letter P is the present value or the present worth. Capital letter A is a single payment of series of N meaning whatever number of years that is of annual payments. So you can think of the letter A as annual payments, and finally as F, the future worth. So there's a P value, an A value, and an F value, and they're all based on the interest value and the number of years in which it's going to be borrowed. So the first example that they're going to give us is what they refer to as, notice they're still using these parentheses over here on the right side to indicate a formula. So formula 4-4, right? Formula 4-4 is this one right here. Let me highlight that while we're watching. 4-4. So the future worth is going to be worth whatever the present value is times 1 plus the interest percentage raised to a value of the number of years that I'm going to be borrowing it. All right? So this is known as a single sum future worth factor or a single payment factor, and the term is also known as F/P. But mostly it's known as find F given P. Find F given P. And there's some tables here that we're going to look at and get really familiar with here in just a moment. So let's take a look at our first example. All right, so here's a list of all the different types of formulas and factors that we're going to be using, and you can see, wow, this is pretty complicated looking, right? All right, so here's our first example, 4-3. If $5,000 was deposited in an account that paid 10% interest annually, what would be in the account at the end of 5 years? Okay, so P, we're find F given P, right? So this would be F/P. F/P. Find F given P, given the interest rate, given the number of years. Okay, and then this is how it gets calculated out, right over here. All right, so let's go back down here to my first problem, equation 4-4. All right, so they're saying F is worth 5,000. We're going to multiply it times some factor, and the factor they're saying is going to be 1.611. We're going to take $5,000, and we've got this table on page, it's on the next page, all right? Yeah, it's actually a couple pages over. Right, so here it is. Here's table 4-4. Notice this is for interest factors where I is equal to 10%. So back in the old days, you used to have this book, and this book would show what the interest rate would be for 5.5%, 5.6%, 5.7%, 8, 9, and so on and so forth. And so those all had to be calculated out. So in this section here, this table said, because we're looking for find f given p, see fp, and over here is the number of years, and we're going to take this value here, 1.6105. What did the book say over here before? It didn't say 6105, it said 611, so it rounded it. So things get rounded here a little bit in the book, and notice it even tells me that the difference between the two numbers is because of the rounding of the factor in the tables, and it's not usually significant. Could be. Let's look at our table. So back in our table, right, the next example, 4-3, this is how it does the work. And so notice I've highlighted this. Find f given p. Here's the p. Here's the interest rate, 10%. Here's the number of years, 5 years. There's the present value, the $5,000 that I'm going to borrow right now, and here is the formula that it's going to use. So I had it calculate that value right here, and notice when I click in here, it's going to actually show me in this function, in this formula block, how this works out. Might be kind of hard to see this, but when you download it and look at it yourself, you'll be able to see this. So notice I've highlighted up here in the formula field, and I've got the mouse over here to the right-hand side. And when I move the mouse over to the left, the cursor moves over, and sure enough, now it's showing that that I'm not on any value here. I'm going to move over again where it's on the 4 of B4. And watch what happens. It's got the PV highlighted, right? The present value. So notice that this is bold down here when I'm up here in the symbol. So I'm going to get this mouse out of the way, and I'm going to keep moving over. And notice that that is a negative value, right? That negative 5,000. When I keep going over, right, notice it then says I'm on B0. And what's bold now? The payment. Well, there isn't a payment. There won't be an annual payment here. We just want to know what it's going to be worth at the end of 5 years. But because of the way the formula works, I have to put a 0 in there as a placeholder. Next one over. When we get to B6, right, column B, row 6 is the 5, and notice it says N per, the number of periods, the number of years. And when I move over to B5, notice it says the rate. B5 is the 10% interest rate. And sure enough, there it is. And it calculates out, right? I'm going to escape out of here again. It calculates out to be $8,052.55. And what did the textbook tell me? It says it's $8,053, so it rounded up. All right, so that's how it did that work. All right, back to Excel. I want to show you this table again, right? So this is the table I was telling you about. Here's my interest tables. This is a handy interest table that you'll be able to download from the Blackboard. And this is called interest tables. In Blackboard, I have it listed as the interest table under the MAR table catalog. By the way, MAR stands for the minimum attractive rate of return, which is also known as a discount interest rate. All right, so this file that you can download here looks just like this. Now look what you can do with this, right? So notice up here in this block, in C1, this block right here, when I click on it, it says 10%. I literally typed that in. And so the calculator portion of this is over here on the right side. Notice here's the letter I. The letter I here, that's just I, stands for interest. And this block right here, N2, N2 shows that it's pointing at, this is just a pointer to whatever value is stuck in over here, right? Let's come back over here to N, all right? So this N figure, right? that is the number of years, right? And because this is set, because I put 5 in here, it's gone ahead and it's moved, it's found out which of these columns has, it's actually updated data over here for every one of the columns that's listed over here. So notice, we said 5 years, right? So here's the 5-year mark, and we wanted to know what? Let's go back and look at it. We wanted to know, find P given F. Find P given F, right? And at the 5-year mark, at 10%, right? The 5-year mark, this is 5 here, 5-year mark, notice find P given F, that's the cell. There's the 5 years, there's the 10%, there's the 6.11 right there. 6.11. So I don't have to dig it out here. That's what they did over here. They did the good work for us. Find P given F. Notice they give it to me right here. Right here. All right. So that's what this table does for me. If I would change this to 6 years and hit enter, notice now it's picked the cell below it, 1772, 17716, right? So that cell is the same as this cell. So this table can do lots of really great work for us, right? And I'm going to put that back to 5. What if I wanted to change the interest rate? I don't change it here. No, 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 no. Don't change it over here in cell N2. You want to change it over here in cell C1. Change it to 5%. And when I change it to 5%, all my numbers changed. It's like a whole different page in the book. So it's not like looking at this page anymore, right? It's not like looking at this page anymore and finding the one that says 5%. I literally typed in the value. And so this is a really handy tool. And I hope you can see that now. Back to my spreadsheet. Change this back to 10%. Control Z. I want to. I wrote it down on the page before, or on the Blackboard page right here. Here's a handy file that can be used to emulate any of the interest tables listed in the text. Make sure not to save any changes that you make to the file after using it. So when you're done with this file, don't save it. Don't save it at all. Okay? Because if you change some stuff, you may not know exactly what you changed, and that may not function correctly. All right. So the tables that we have, we can find the annual payments given the present value or worth, or we can find the annual payments giving the future value or worth, or we can find the present payment, the present value if I know that I'm going to get $10,000 a year for 5 years, or I can find what the future value is in 5 years, what that money is going to be worth then. So very powerful tools here. And what follows next in the text are several different examples, right? So that was find F given P, all right? So example 4-4 is the next one, right? Example 4-4, let's read what it says. Energy manager wants a boiler to last 7 years, and he thinks it'll cost about $150,000 to replace it at that time. So he's planning ahead. I know this, I'm going to be able to make this boiler run for 7 more years. I'm going to keep it going. I know that the cost of maintaining it's going to be high, but I'm going to keep it going. So in 7 years, how much money do I need to put away now to be worth $150,000 in 7 years if our MAR is 10%? Okay, so if I know that I'm going to need $150,000 in 7 years, how much do I need to put away now? All right, and so notice the equation that they used here. So this particular one is what? Notice the P comes before the F, right? So that means find P given F. 10-year period, or 10% interest for 7 years, again using the table 4-4. Well, I'm not going to go to 4-4 anymore. In this case, well, I will. I'll go to 4-4. Let's Now we'll go to this spreadsheet here. So again, we're back here. We're on 10 years, right? This is 10%, and I want to know what that value is. Well, what was it we were looking for? We were looking for find F given P. I'm sorry, find P given F. Find P given F. All right. Find P given F. So back to the spreadsheet. Here it is right here. This is the column. Find P given F. And I come down to 7 years, and it tells me that that multiplier is 0.5132. What did the textbook tell me? Sure enough, 0.5132. That's that same value that we had there. So I multiply that times the amount of money I think I'm going to need in 7 years, $150,000, and that tells me I need a little more than just less than $77,000. That's what I need. Well, again, back to the spreadsheet. If I didn't want to hunt this out and scrape this down, instead, I could just come over here and click on this file, on this N, right? This is the number of years equals, put a 7 in here, hit enter, and sure enough, find, and this is the cell I'm looking for here, right? Find the present value of the future worth, and there's the 5132 that I multiply times $150,000 in the example. All right, so that's what the rest of these examples are about, right? That's what the rest of these examples are about. Let me show you how I did some of those. All right, so here's number 4. Number 4, I put the formula in, find the future value given the present value. I wrote that down wrong. This would be, yes, that's backwards. We want to find the present value given that. All right, so let me change that here. Let's say we will find P given F. And I will make it bold. All right, find P given F. And so there's my formula. Now, so again, here's the future value. Here's the 10%. Here's the future value. Here's the 10%. Here's the 7 years. When I click on the cell where I put the equal sign, so equals PV, present value, right? Present value is going to be equal to whatever's in B5 times whatever's in B6 times 0, or skip this, times the negative value of what's in B4. Well, let's back up here. All right, so let's do this the other way. So again, when I click up here in the cell, it's going to show me, as soon as I get on one of the characters, it's going to drop down and it's going to show me how Excel looks at it, right? So Excel looks at it using different things. They refer to, here it has there's one called type. The last one is type. The fourth one is future value. The third one is payment. The second one is the number of periods, and the first one is the rate or the interest. All right. So notice that these last two have brackets around them. By having brackets, that means they're optional. I don't have to use a value there. And if I don't use one, I don't even need to put a 0 in there. So in this case, because I'm now in between the B and the 4, notice FV is what's bold. And because FV is bold, that means that this value that's inside B4, this 150,000, that is the future value. Now I'm going to keep moving back negative. All right, so this is a negative number I have to put in here. All right, I have to put that negative number in here. If I don't put a negative in front of it, then the calculation isn't going to come out right. Okay, notice now I'm in the cell, or I'm in the section of this function with a 0 in it. And what's highlighted? PMT. All right, PMT. Well, there is no payment made in this 7-year period. So I have to put a 0 in there because it's not bracketed out. So I have to null that out, is what that's referred to. N-U-L-L, null it out. Keep moving over. B6 is the number of years, N-P-E-R, N-per. And then finally B5, and B5 is the rate, the interest rate. So there you go. That's how these work. I'm going to cancel out of this one. Now, What would happen if I got rid of that negative value that was shown there, right? Remember this negative B4? I'm going to take that out of there just to show you what happens if I get rid of the negative. Boom, it says it's worth a negative value of money. Well, that's not a negative value of money. I can't have a negative 76,000, right? So I have to come back and I have to put that negative back in here, and that's going to change that back into a positive value of almost $77,000. Again, notice this number, the 76,973, is not the same as what we showed here, right? Because of the rounding error. See, they say 76,980 here, and on the spreadsheet, I come up with $7, $6 and 28 cents last. Okay, so that's just a rounding error. All right, so that's that example. In the next one, 4-5, we're going to have another series. This uniform series is all shown here, and so these are all the different tables that we have. Okay, it's a bit complicated, especially if you haven't horsed around with this stuff before. Energy in number 4-5, okay, 4-5, which we're going to have an example of. We got $5,000 a day available today to buy a high efficiency air conditioner, which should last 6 years. So she wants to know, are we going to save enough money to spend that $5,000? Well, let's find out. Normally, the money that we would like to take out of the company's reserve is pulling down 10% interest. It's pretty good interest. So will that offset, will I save enough energy to offset the amount of money that would be saved? So we're going to have to do, in this type of conversion, we're going to have to find what are the annual payments if I know what the present value is. How much money do I need to save every year in order to make up for the 6 years of lost interest on that $5,000 principal? And so in this case here, again, we go back to the table. We're going to continue using 10% interest in the example so that we could stay on the same page, right? So if I go back to the spreadsheet and I go back to my interest tables, and this time I say 6 years, and I hit enter. And again, what were we looking for? We were looking for find A given P. So back to the table. Find A given P. There it is right there. There's A given P. So 0.2296 is what it says the multiplier is. That's what we multiply times the $5,000. Sure enough, there's the 2296, right? And when we multiply the two together, we come up with $1,148. That's what we would need to if the projected savings of electricity costs is greater than $1,148 every year, go ahead, let's do it. So let's go back and see what that table looked like. So here we have 4-5. Again, I put it in here, find A given P, right? And I typed some of this out to help you here. The rate times the period times the negative value, if there was a payment, and then the type. And because this is a PMT, this is the Excel equation or function, right? You start it with equals PMT, and it shows the three things that we need, right? And the three things that we need before is the present value. Sure enough, B4, that's the $5,000, and we have to make it negative. B6 then is the number of years, and the rate shows up in B5. So there we go, and it comes out to be $1,148.04. Textbook tells us they skipped the 4 cents. That's just fine. All right, let's just go through the rest of these then. In this case here, we have a heat pump. It's supposed to give us cost savings of $1,500 a year for 20 years. So we want to know is what's the equivalent amount of money worth today, right? What's today's value worth if I know that I'm going to be getting $1,500 a year for 20 years at 10%? So again, find P given A. Find P given A. We go back to the table. Find P given A. Here's, let's see, P given A. That's this table right here. This table right here. Find P given A. We come over here. We're still at 10%, right? There's our 10%. We're going to come down here to the number of years, put in 20, hit enter, and find P given A. It has a multiplier of 8.51. Find P given A. What did we say? Find P given A down here at the 20-year mark. Sure enough, 8.514, right? So that value is pretty much, this value here is pretty much the same as this value here. And the textbook uses, look at that. So that's how these work. So this $12,770 is worth in today's dollars what a series of annual costs would be. So if we can get this thing for less than $12,000 or less than $13,000, then that's going to be a good investment. 4-7. We need to start putting money away for a new boiler. That one we talked about that was going to crap out in 7 years. I'm sorry. So how much in annual deposits do we need to put away in order to have 150,000 in the bank in 7 years? So we want to know is what do we need to put away every year to be worth 150,000 in 10 years? Well, that's kind of neat. So this is find the annual amount if I know that a future amount is going to be $150,000. So if I need 150,000, how much do I need to put away? So this says find A given F. All right, find A given F. Let's go back to our tables. Okay, find A given F. That's this one right here, right? We needed to change this to 7 years though, didn't we? 7, enter. And find A given F. Multiplier is 1.054. Find A given F. Right, 1.054, sure enough. So if I multiply 150,000 times the 1.054, that's going to give me this value. So let's go back to that table and find, where'd my table go? Here it is, find A given F. So there's $150,000, there's the 10%, there's the 7 years. When I plunk down here in C3 is where I put it, it's going to then show me the value, and when I start moving up here, it will give me this. So the reason I'm walking you through all this is there's a bunch of questions in the back of the textbook, and you're going to have to try and figure out which of these formula that we've gone through here in the book that you'll be applying to those examples. And just like I started doing in chapter 3 last week, I'm going to give you the answers. And then, so what you have to do is using the answers and these spreadsheets that I've shown you, you have to show that you can use those tools to solve those problems. It's not as easy as it sounds, but I know you're up to it. All right, next one. High efficiency lighting project. Company is going to be saving $10,000 a year in energy costs. If we deposit that $10,000 into an account paying 10%, how much money will be available in 5 years? And we're going to use that money to replace the old chiller with a new high efficiency model. So this is really neat. We're going to leverage energy savings with one project to pay for more energy savings for the old chiller that's going to be due for replacement in 5 years. So this one's kind of neat. So in this case here, we've got our $10,000, right? That we're going to be saving every year because of that lighting project that we did. We're going to put it away for 10 years, and we're going to find out just what is that going to be worth at the end of 5 years. Well, we know it'll certainly be worth 5 times 10,000, 50,000, but how much more interest will I make? So this is find F, future value, given the annual payments shown here. All right, so find F given A. Again, we'll go back to our slide, our spreadsheet. Ooh, it's disappearing. It's way back here. Interest tables, 5 years. Find F given A. Let's see, so we want A dash F. There it is right there. The number is 0.1638. What does the book say? Oh, let's see, find F given A. Did I look at the right one? Oop, I did it backwards. Find. Well, I don't see it. They don't have a sheet for it over here. Okay, so find F given A. That's going to be this right here, 5 years, 6105. I think it's probably worth pointing out here that find F given A and find A given, we'll just leave it there. So there's the formula we needed. So this table didn't do everything we wanted it to do, but we do know that if we multiply the 6.105, just like it shows in the book, 6.105 times 10,000, there's our value. All right, so that was the start of this. I'm going to end this recording right now and put up part 2 here in a minute, which is going to talk about a couple other things. So that's